Alright, so I'm going to start you off with a prompt here. Everything's already given. I have here a purple square that has the dimension of x by x. We have actually just one tile here, just situated differently. One's horizontal, one's vertical, but notice that the length of that is x and the width is by 1. So I'm going to basically use a series of tiles here and the square, purple square, to make up this figure, which is also a square. And I can have you see here that when I put these together, I have 4 tiles on the right hand side of the square and 4 tiles on the bottom of the square, extending it outwards. And so in itself, if you see the overall picture, it will still be a square. Your task here is to find this missing square, as you can see. So go ahead and take a couple of moments here to figure out what is the area of this missing square. Okay? All right, let's do that. Okay, so you clearly see that for the width of each tile is exactly 1. Okay? You have 4 tiles like that. That in itself will give you a extension of 4 units. The square itself has a side of x, and because it's also extended the same way on the other side, you also have x extended by 4 units. Okay? And clearly, if this is 4, then this distance from here to here is also 4, and that will give you a 4 by 4 dimension, and the square inside, which will give you a total of 16 as the entire area. Okay? Now, to complete the square, is it true that you clearly see that you have, first of all, the area of the purple square, which is x squared. The area of each tile is exactly 1x, so since you have exactly 8 tiles, you have 8x as your area, and you also have the missing square included. So if I ask you to find the entire area of this square, is it true that it is a total of x squared, which is the purple, plus 8 tiles, that is 8x, because each tile is 1 times x, which makes it x, and you have 8 of them, that's 8x. And the missing square itself has an area of 16. And look what we just got here. We got back a trinomial representing the entire square. And that itself shows you that we have a missing square of the area of 16. Now I want to show you something more than that in the past when I gave you a trinomial, and factored out using, for example, in this case, this is we have a 1 in front of x squared, so we certainly just use an x on it. We have 16 here on top, 8 in bottom, and we have 4 times 4, which makes it 16, and add up to 8. And when we go ahead and write it when we factor it out, you simply have x plus 4 times x plus 4. And I hope you see a connection here from the picture and the factor itself. Notice how we got the x plus 4 here. X plus 4 times x plus 4 is the area of the entire square. And notice that we also have x right here as the side of the purple square and extended 4 units. So the total length here is simply x plus 4. And same thing here, x plus 4. And that's how we got the area of the square outside of the x plus 4 times x plus 4. That is the first connection I want you to see. Secondly, if you notice here, this 4 right there is in itself the side of the missing square inside, okay? Because remember, we extended 4 units both way, which makes up our smaller square, the missing square, which also have a dimension of 4 by 4. So try to keep that in mind as we continue towards our next example. And by the way, since we have x plus 4 times x plus 4, we can actually condense it and write it as x plus 4 squared. Okay, just another way to write it in the condensed form. Okay, let's take a look at our next example here. So the key thing I want you to get out of this is that, yes, it is true that all that we have to do is to complete the square. So for instance, I have this example, b squared plus 6b, and I'm asking you all, okay, I want to make this a complete square. This is all I have for you right now. So if you were to do it pictorially, it's a b by b, and since we have 6b, meaning we have 6 tiles of b like that, if we were to go ahead and put it into this pictures, is it true that you would also try to have 3 tiles on each side of the square? And now, when you see this as an entire picture, you see us missing square. And the missing square, as you can see, is exactly 3 units by 3 units. And so we can conclude that the area of the new missing square is 9, because it's 3 times 3. So we can certainly put that back in here to say that now we have a complete square. So this process is what we call completing the square. Okay? And because we have completed this square, it now becomes factorable as well. And for those of you who actually recognize this to be a perfect square trinomial, it's a PST, we can easily factor it. Or if you want to go back and use the old technique of using the x for it, here's the 9 here on top, and here's the 6. The reason why I don't use a box after the x because this is a 1. And what times what is 9 added to 6? It turns out to be 3 times 3. And it's not a coincidence for you to see that that 3 that we got here from the x is also the extension that we actually did on each side of the square. That values came out to be exactly the same. Okay, so when we have it, we can simply say, oh yeah, so the expansion of this is b plus 3 times b plus 3, or we can condense it to write it as b plus 3 squared. And I hope that makes more sense now to see that there it is. That's how we get the b plus 3 and the b plus 3. Because essentially, all I'm asking you is to find the area of the square. Area of the square, as you know, is side times side. And so from the picture, we can see that. And most importantly, I also want you to see that how we got the side itself. I mean, if I don't have to draw a picture on every single problem, is there a way to decide what the side of the missing square is going to be? Well, if you take a look at it carefully, every time we have the number of slabs that we have, we always tend to cut it in half, and that number, the half, after we take the half, that number tends to be the side of our missing square. After we find that, we square it to get the area of the square. So kind of keep that in mind. Another thing that I want you to take a look at and to pay attention to is that every time I do something like this, everything seems to be in order. Notice that I have the square term, I have the b terms, and the constants is last. Everything is in order in that fashion. So kind of keep that in mind. Let's try another example here. So this time I'm not going to draw any pictures. I'm just going to give you a straight example out of that. So if I have y squared plus 10y, and I ask you to go ahead and complete this square, what is that area of the missing square will be? And hopefully by this time you recognize that, oh, well, in this case, since I have 10 slabs of y or 10 tiles of y, if I'm going to split in half, that means I will have exactly 5 tiles on each side. And that number right there will indicate that means the missing square will be made up of 5 by 5 tiles. So in other words, the area is 5 times 5, or 5 squared. So that means I will get positive 25. And if I want to go ahead and factor this, notice that the picture that we got before, you certainly can relate back to it since we extended.
And Carla Guerrero report to the front office. Ariel Barragan and Carla Guerrero report to the front office.
Since we extended 5 units on each of this on the side of each square, we know that if we factor it, it's going to be y plus 5 times y plus 5. Okay, and we can condense it to be y plus 5 squared. Okay, and let's try one more here. What if I have the following? And I actually complete the square. Okay, find the area of the missing square. And at this time, you say, wait a minute, this is an odd number. It won't be divided evenly. But that's okay. We can certainly have the whole tile or half of the tile is necessary. But in this case, we know we have exactly -5 tiles. I know it's okay to use negative, by the way. And we cut in half. That means we have exactly around 2.5 tiles, right? Remember, the reason we don't care about the negative because at the end, when we square it, we get back the positive answers anyway. So we get back -2.5, and we know that this here will represent the side of the missing square, right? Side of missing square. And once we have the side of the missing square, we just square it, and that will give you the area of the missing square. Okay? So we can certainly take -2.5 squared, or for those of you who don't like that and keep it as in decimal form, meaning this one, we take -5 to half and square it, you add it with 25/4, and that is definitely an acceptable answer. And I prefer it to be in fraction form. And if you were to factor it out, remember, factor is basically what you extended beyond your original square, which is b by b. How far did I extend it? Well, in this case, I extended exactly 2.5 units, but negative 2.5 units to be exact, right? And in fraction, that's negative 5 over 2. So when you expand it, you would just write, oh, it's b minus 5 halves times b minus 5 halves, which means I have b minus 5 halves squared as an extension. And hopefully you get that so far. Okay? All right, continue on to this next one right here. And you're probably going to have questions about, well, why do we need to complete the square in the first place? How important is it to complete the square? As it turns out, all that we've done before is just try to complete the square, finding that missing square to make it complete. Here I have myself an equation. And as for any equation, you are required to solve for the missing variable. What is the value of the variable to make it true? Okay, and so when you try to solve for this, ideally, in the past, we always want to try to use the property that we've covered. In this case, the Z2P, zero product property. So what you want to do is just go ahead and make sure, first of all, everything's sorted, everything to one side, and I end up having this. Yes, okay, and I have a 0 on one side and can start using the zero product property. I look at this right here to see it's factorable, and indeed, that's when I try to set it up to factor. I found that 12 and negative 2 works just fine. And because, once again, I don't need a box because this is a 1, therefore I can just take what I have here and transfer it over. So it's x plus 12 times x minus 2 equal to 0, and I can quickly break into two cases and solve for 0. And on this case, I will have negative 12, and the other one I will have a positive 2, and I'm done. I mean, I can plug them back in and test them, and it works just fine. Now, you're saying, so how are we going to apply to what we just learned a while ago to this kind of problem? First of all, let's just say something. You went through this problem and you moved the 24 over, trying to use the zero product property. Some you set up your x like this. You got your negative 24 up and you get your 10. And you try, oh, the only thing you can come up with is 6 and 4, but it didn't quite work out, so you say, oh, I give up, didn't work out. If you ever felt that way, then the second method is the method for you, completing the square. So in that way, what you could have done is, so you tried everything you can and it didn't work out, and the method I just showed you earlier, completing the square method, will be the best for you. I'm going to show how it's done. First of all, you still have to make sure everything is in order. Everything has to, be in order. X squared, x, and the constant, of course. Another thing that you want to check for before you even start completing the square is that this coefficient in front of the square term, is it actually a 1? If it's not a 1, we have to take care of that somehow. So in this case, it's a 1, so it's good to go. It's a good sign, and so what you need to start is think about this. This previous case didn't work out for us, so that means this negative 24 we don't need. Okay, the constant, we just get rid of it by moving it to the other side. Okay, so by moving it to the other side, we add it over and we end up with this. And if I kind of covered this up a little, the side of the 24, you just have x squared plus 10x, and if you recall how we find that missing square, we take this right here and we cut it in half, right? And that will give us 5, and then we square it, that's going to give us 25. So therefore, our missing square area is 25. And here's the thing about equation, though. If you know that whatever we do to one side of an equation, we got to repeat that and do it to the other side as well to maintain equality. So because we just added a brand new value to the left-hand side, 25, we also have to make sure we add that value to the other side as well. And here on the left-hand side, all of a sudden it becomes a perfect square because we just completed the square. And we know we just made an extension of 5 on each side, right? So therefore, the original square, this one right here, after we expanded 5 on each side, we have the total dimension of x plus 5 on each side. Or if you don't want to do it that way, you want to do just an x on it, you can clearly see that it's still 5 by 5. So it's x plus 5 times x plus 5, or we can just write it as x plus 5 squared. Okay, and on this side though, it's going to be 49. Now, why is it that we want to write it in condensed form? Because back in chapter 10, if you recall, we know how to solve for the square and the square root. And if we want to solve for x in this case, or axis in this x, we have to get rid of the square. And to axis is, to get rid of the square, we can square root both sides. And you can clearly see that x plus 5 now is equals to, a lot of you will say, 7. But please think about this. Is it true that when we have something square, doesn't matter what value it is, when you have it square, it will become positive anyway. So when you take the square root of 49, instead of having just a 7, it is possible to have negative 7 as well, because negative 7 squared will give you 49 anyway. So I want to make sure that you have this written down and memorized, because you need to make sure that every time you take the square root of a value, in this case you have both answers, positive and negative. And now when you try to wrap this up, you will subtract the 5 both sides, and you have this, x equals to negative 5. First case, because you have positive negative, you have plus 7. And the other case is negative 5 minus 7. And when you work that out, you have a 2 and a negative 12. And if you have to compare your answers to the previous one that we just did earlier, notice that we got the same exact answer as well, 2 and negative 12. Okay, and there it is. Hopefully I can convince you that by completing the square, it makes a lot more sense for problems that's not factorable. Okay, let's try another one right here. Same kind of deal. Remember, we want to test it out to see if it's factorable or not before we resort to completing the square. So the first thing I do is, as always, before I do anything, is try to put them in order. So I'm going to go ahead and move the 10x over, and if you were to write it like this, you clearly see that it's not in order yet. So I'm going to have to switch the 15 and 10x around, and that will give you 10x plus 15 equals 0. You can certainly try your x here, try to factor it using x, and nothing works out. Just can't do it. Then you got to think about completing the square, meaning I don't need that. Didn't work out for me when it was with me, so I'm just going to go ahead and toss it to the other side. What I end up with is this, okay? X squared plus 10x equal to negative 15. Now I have to find my new square, and the method is always the same, right? I have 10 tiles like this. I'm trying to split in 5 both ways, so cut in half. And then basically I have 5, and then I square that. That will give me the area of the new square, which makes it 25. Okay, just to remind you of that. But because if I add on one side, I also have to do it on the other side as well. Okay, and here, this is a PST automatically because we just completed the square. I can readily write it out as x plus 5 times x plus 5 equals 2, in this case, 10. I can condense it. For those of you who want to just write in condensed form to save a step, I think you should. That'll give you that. And then I can just take a square root both sides. It's going to be x plus 5 equals 2, don't forget, plus minus root 10. I can subtract the 5 over now, and that's going to give me a negative 5 plus or minus root 10. Okay, that's basically the answer. Certainly expand it into, if you're lazy and you just want to write it as a plus minus like that's fine, but if I have 2 separate answers, you definitely want to write it as negative 5 plus root 10, and the other one is going to be a negative 5 minus root 10. Okay, 2 separate answers. Okay, so the last problem that I want to talk about today, obviously, would be this problem. And I kind of warned you ahead of time about the case where the coefficient in front of the square term is not a 1, and this is the case that I want to talk about. But first and foremost, I still want to go ahead and put everything back in order. So I'm going to move these 2 terms over. So I have 3x squared plus 18x minus 15 equals 0. Notice I'm just performing the opposite operation to move it to the other side. I can also try to do the original Xbox method if I can. So that's negative 45 on top. How do I get that? It's 3 times 15. And 18 in the bottom right here. Nothing works out for me. I tried 15 and 3, didn't work out. So I can say, well, I need to start trying to complete the square. But because I have a coefficient in front of x squared that is not a 1, I have to somehow get rid of it. And the only way to make it into a 1 is by dividing it by itself, the coefficient by itself. But you know, because in the equation, whatever you do in one side or one term, you've got to do it to every single term to make sure that you spread the equality around, right? You want to maintain equality. So there it is. What you have left is x squared plus 6x minus 5 equal to 0, and of course it's still not factorable. So therefore, I'll say I don't need you negative 5 anymore. I'm just going to go and toss you to the other side. I just want to maintain my variables on one side. So I toss it over, and this is what I have. My new area of the square is going to be half of 6, which is 3, and square that, which will give me 9. And don't forget, once again, if you're going to add 9 to one side, you have to add it to the other side as well. And this is automatically a PST. We just completed the square, so I can just go ahead and factor it out, and we got it to be like that. A quick reminder is, remember, this is the side of your big square, and we just extended 3 on both sides. That's how we got the x plus 3. And this is 14. We take the square root of both sides, got x plus 3 equals 2, don't forget, plus and minus, plus and negative root 14. And we subtract the 3 over, we end up with negative 3 plus root 14. And the other one's going to be a negative 3 minus root 14. That's 2 possible answers. Okay, that's it. And I do have some recommended problems for you to work on tonight. And that's going to be on page 117, 15 through 16, page 118, 2, 10, and 15. And that's it.